Hello, it's Mr. Rops here. We're going to do an example when we're combining normal random variables, since we've already thought about that earlier. Now here's an interesting fact. If x is normal with a mean and its variance, and y is also normal with its given mean and variance, well, when I combine them together, z is also going to be normal. The mean, though, is going to be mu a times mu of x plus b times mu of y. I add them, plus c, and the variance, I'll write it up top here, is going to be a squared, the variance of x, plus b squared, the variance of y, but no plus c because that's the shift. If this would have been subtracted, if I would have made this subtracted, then this here would have been subtracted, but this still would have been adding, because we always add variances, but the mean or expected value can be added or subtracted. Okay, so that's just an interesting fact that you should know. All right, here's our example here. We have a crate of oranges, and this is going to be 200. You can change that on your notes if it hasn't been noted. Crates of oranges, and so imagine you have a crate of orange, you have crates here, and inside here are oranges. Okay, they are normally distributed with an average weight of the crate being 4 kilograms with a standard deviation of 40 kilograms. So all of this together is going to be, we'll call it C, is normal with 4,000 grams. And I'm going to do grams because this is grams, grams, kilograms. It just seems a lot of grams. So we'll use grams as our unit. So 4,000 grams. And the standard deviation is 40, so the variance is 40 squared. The crate themselves, so meaning the wooden part of the box, so we'll call that the box, is also normally distributed with a mean with a weight of 100 grams and a standard deviation of 5 grams. The cost of the actual oranges, so just these oranges, are 49.9 crowns, Czech crowns, per kilogram. So that means the cost is 49.9 crowns per kilogram, which is the same. If I divide by 1,000, 0.0499 Czech crowns per gram. Okay, so it wants to determine the mean and standard deviation of the cost of the oranges. Well, oranges, I know if I take the actual full crate minus the box on the outside, that will be just the weight of the oranges. And if I take that weight in grams and multiply it by 0.499, let's move this over. I go 0.0499. This will be the cost of the oranges. And so my expected value for oranges is going to be the expected value of 0.0499 times C minus B. Well, using my rules of algebra on expected variables, or random variables, this can come out times the expected value of C minus B, which is 0.499, which is going to be times the expected value of C minus the expected value of B. And I'm going through all the details of the algebra here. 0.0499. Well, the expected value of C was 4,000 minus the expected value of B was 100. And if I multiply this all out, I end up with 0.0499 times 3,900. I get 194.61. So my expected cost of just the oranges, not the box, is 194.6 crowns. My variance of the oranges, well, doing this calculation, is going to be the same scenario here. I'm going to go the variance of 0.0499 times C minus B. Using my algebra rules for variance, when I pull this out, it ends up being 0.0499 squared times the variance of C. If I'm subtracting variances or random variables, I actually still add the variances. Be careful of that one. And so now it's 0.0499 squared times the variance of C. Well, that was 40 squared. The variance of B was 5 squared. So 40 squared plus 5 squared. And so my variance is going to be 0.0499 squared times 40 squared plus 5 squared, which gives me 4.046. And so the standard deviation of O will be the square root of 4.046. And so that will answer my question here. I know the mean and the standard deviation. Mean. And so now I can say that O of oranges, the cost of oranges, is normally distributed with a mean of 194.61 and a variance of 4.046 squared. The question now says Ola buys a crate of oranges in terms of probably the oranges cost more than 200 crown. Well, I know I want to find the probability that the oranges are more than 200 crowns. Well, now I'm just going to do normal CDF, so I'm going to go to my distributions. I'm going to do my normal CDF. I know I'm going to go from 200 if I think visually. Here's my normal curve. Here's 194.6. The 200 is here. I want all this area. So that means my lower bound is 200. I'm going to go to some big giant number. My mean was 194.61. My standard deviation was the square root of 4.046. And I end up with a probability of 0.00369. That is 9 rounded to 3 significant figures. And so the probability of costing more than 200 crowns is quite low indeed. So we use our random variable algebra to determine the new mean and variance, and we use that then to determine the probability of orange costing more than a certain value.